Hello everyone, welcome to my presentation. Before we begin, I want you to think about one simple question. Have you ever looked at students' marks, project results, or experiment outcomes and wondered what does this data actually tell us? In STEM education, data is everywhere, but numbers alone do not help unless we understand them. In this video, I will explain measures of central tendency and variability in a very simple way, using classroom and STEM-based examples. My name is Elina Gurung. Today I will be talking about how we can understand data in STEM education using simple statistical ideas. We will learn how to find the average, the middle, the most common value, and also how to understand the spread of data. In STEM education, we generate a lot of data. This data can be test scores, project outcomes, experiment results, or even sensor readings. For example, in one STEM project, some students may finish very quickly, while others may take more time. By analyzing data, we can improve teaching methods, learning activities, and innovation. Data helps us make decisions based on facts, not guesses. What is central tendency? Central tendency means finding the center or typical value in a dataset. Instead of looking at every single number, central tendency helps us summarize the data in a simple way. In a STEM classroom, it helps teachers understand overall student performance. There are three main measures of central tendency: mean, median, and mode. The mean is what we usually call the average. To find the mean, we add all the values and divide by the total number of values. For example, if 5 students scored 85, 90, 78, 92, and 88, the mean score is 86.6. The mean helps us understand the overall performance of a group. But we should remember very high or very low values can affect the mean. The median is the middle value in a dataset. First, we arrange the numbers from smallest to largest. The value that comes in the middle is the median. The median is very useful when there are extreme values. For example, if project completion times are 2, 3, 5, 20, and 25 hours, the median is 5 hours, which better represents most students. This is especially helpful in diverse and inclusive classrooms. Mode. The mode is the value that appears most often. It shows what is most common in a dataset. The mode is very useful for choices and preferences. For example, if most students choose Python as their coding language, then Python is the mode. Teachers often use the mode to understand student interest. Now let's imagine a real classroom situation. Students are asked which STEM subjects they like the most: science, technology, engineering, art, or math. After counting the responses, the subject chosen by most students becomes the mode. This helps teacher plan engaging lesson plans based on student interest. Central tendency tells us the average, but it does not tell us how different or similar the values are. This is why we need measures of variability. Variability helps us understand consistency, diversity, and reliability. Two classes may have the same average score but very different learning outcomes. The range is the simplest measure of variability. It is calculated by subtracting the lowest value from the highest value. For example, if robot build times range from 30 minutes to 90 minutes, the range is 60 minutes. This tells us how far apart the fastest and slowest results are. in quartile range, IQR, focuses on the middle 50% of data. It ignores very low and very high values. This helps us understand the typical performance of most learners. A small IQR means the data is more consistent. IQR is often shown using a block spot. To conclude, data is not just numbers. In STEM education, data helps us understand learners, improve teaching, and create better learning environments. Measures of central tendency and variability helps us see both the average and the differences in learning outcomes. The next important step is interpretation. In STEM education and data analytics, numbers alone are not meaningful unless we interpret them within context. For example, an average score may look acceptable, but it may hide significant differences among learners. Therefore, central tendency always should be read alongside classroom context, learning design, and student diversity. At master level, data analysis always begins with a research question. Different measures of central tendency answer different types of question. For example, the mean answers questions about overall performance, the median answers questions about typical learner experience, the mode answers questions about common patterns or preferences. Selecting the correct measure is not a technical decision alone, but a research and pedagogical decision. In real STEM classrooms, data rarely behaves perfectly. Learners progress at different speeds, use different strategies, and have different levels of access and support. Because of this, relying only on the mean can be misleading. In such cases, median and variability measures provide a more realistic understanding of learning outcomes. Variability is central to understanding learning differences. In STEM education, variability can reflect different problem-solving approaches, unequal access to resources, diverse cognitive and creative strengths. High variability does not always mean poor learning. Sometimes it indicates creative exploration in STEM tasks. For educators and researchers, variability is not a problem to eliminate, but a signal to investigate. Large variability may suggest a need for differentiated instruction, scaffolded learning, or redesign of activities. In this way, data analytics support reflective teaching practice rather than standardized instruction. Educational data often includes outliers. These outliers may represent learners who need additional support or learners who are progressing much faster than others. Measures like the in-quartile range help researchers focus on the central learning group without ignoring diversity. This makes analysis more reliable and ethically responsible. Measures of central tendency and variability are part of descriptive statistics. Their purpose is not only to describe data, but to perform decisions. In STEM education, these decisions may include curriculum design, assessment methods, instructional strategies, and learner support systems. At master levels, data analysis also involves ethical responsibility. Misinterpreting averages or ignoring variability can lead to unfair conclusions about learners or programs. Responsible data analytics requires transparency, contextual awareness, and critical reflection. In summary, central tendency and variability are foundational tools in STEM education, data analytics. When used thoughtfully, they help us understand learning patterns, learner diversity, and instructional effectiveness. For master students, developing these analytical skills is essential for evidence-based practice and meaningful research. So far, we have discussed central tendency and variability as individual concepts. Now let's place them inside the data analytics pipeline. In data analytics, descriptive statistics are usually the first analytical step after data cleaning. Before applying machine learning models or advanced statistical tests, analyst first asks, what does the data generally look like? Where is the center? How spread out is the data? Mean, median, mode, range, and IQR help analysts validate data quality and detect anomalies early. Without this step, advanced analysis may produce misleading results. Another important role of central tendency and variability is data quality assessment. For example, an unusual high mean may indicate data entry errors. A very large range may indicate inconsistent measurement. A wide IQR may suggest unequal learning conditions. Outliers should not be removed automatically. In STEM education, outliers often represent exceptional creativity, learning difficulties, experimental innovation, or skill data analyzed first investigates before making decisions. In data analytics, numbers alone are rarely presented without visuals. Visualizations helps combine central tendency and variability in one view. For example, box plots show median, IQR, and separate together. Error bars show variability around the mean. Histograms reveal distribution shape. The visual tools help analysts communicate insights clearly to educators, policymakers, and stakeholders. A good analyst knows how to explain data visually, not just calculate statistics. Another concept data analytics students must understand is data distribution shape. Data can be symmetrical, positively skewed, negatively skewed. In skewed distributions, mean, median, and mode are not equal. Median often represents data better than mean. In educational and STEM data, skewness is very common because learning outcomes are rarely uniform. Recognizing distribution steps helps analysts choose appropriate summary measures and models. At the master level, data analysis is not only for classrooms but also for research and publication. Descriptive statistics provide the foundation for comparative studies, intervention analysis, program evaluation. Before testing hypotheses, researchers must clearly describe central tendency of variables, variability within samples. Well-reported descriptive statistics strengthen the credibility and transparency of research findings. Data analytics students must also be aware of common mistakes. Some frequent misinterpretations include assuming average represents everyone, ignoring variability, comparing means without context, drawing casual conclusions from descriptive data. Descriptive statistics describe, they do not explain cause and effect. Critical thinking is essential when communicating results. Understanding central tendency and variability prepares students for more advanced topics such as inferential statistics, regression analysis, machine learning, learning analytics dashboards. These foundational concepts act as analytical anchors. Students who skip this stage often struggle later with interpretation and model evaluation. Strong foundations leads to responsible analytics. To conclude this extended discussions, measures of central tendency and variability are more than formulas. They are thinking tool for data analytics. In STEM education, they help us understand learner diversity, improve instructional design, support ethical and evidence-based decision. For data analytics students, mastering this concept is essential for both academic research and professional practice. Thank you for listening.